Okay, so I decided to just record the thing that I'm going to do and show this to you. I'm not gonna send to you the whole uh, SPSS thing because, as I said, if I send it to you and you don't pay me, I don't have a proof that I did that, alright? So, this is what I'm gonna do. I'm gonna show you how the whole SPSS thing works just to prove to you and your guys that I can do this, alright? So, this is the screen of the SPSS, the variable, the data view, and the variable view. The variable view contains uh, pretty much all the variables from gender, age, teaching grade, and all that, right? The label of P1 to P15 is pertains to the perception, and the problem 1 to 14 pertains to the problem. Okay, so we have the values here. I also encoded this, 1 for male, 2 for female, because SPSS does not understand nominal data or strings. It's better to be encoded in numbers. So same goes with age and teaching grade. Now you have a concern for teaching grade because there are responses that have multiple, like response. You can't analyze that in SPSS, so you have to just encode it manually if you want to show the profile of each professor. So what I did was just to get uh, the earliest grade, for example. So if he or she ticked grade 10, grade 11, I just encoded 1 for grade 10. If he ticked 11 and 12, then it's 2. Alright? Anyway, so qualification, it's BA or MA, it's pretty easy. And then teaching experience, I had to encode the whole thing. There's also one response that I couldn't understand. Um, I just encoded it, as I understand it. I think it's the very first one. I'm gonna show you. Okay, this one. As you can see, uh, for me it looks like 11, right? It looks like it's 44, right? But she's just 30 to 39 years old, so it can't be 44. So I just wrote 11 there. Okay, so on with the SPSS thingy. So the first thing that we have to do, I already showed you this. First is the scale analysis, the reliability analysis. You do is analyze scale and reliability analysis. You have to do this one by one. So first, do the perception from 1 to 15, and place it to the other side. The statistics I use is scale. You can do items, it doesn't really matter. Correlations, that's it, correlation. So the reason why I'm using inter-item correlation, so that we will know if there's a problem with the data, if something goes wrong with the data or the alpha, then we can do something about it. Okay, and then we continue, and when I press OK, of course I don't need to do this again because it's already here. The reliability analysis came out as 0.647, standardized items 538. This is for the 15 items, in the beginning, which refers to the perception. Okay, you can see there are um, some of the inter-item correlation reveals that some items are not compatible with other items. But since the Cronbach alpha is, tolerable at 0.647, we can just allow it to go, right? So if you look at this, P3 and P1 is negatively related with each other. That means you have a little problem with perception question number 3, which is, alright, where is it? I have to look at the, damn, I have to look at the data 3 again. So perception, I have to look at it. It won't take a while. So 1 and 3, according to that, is not related. So you have to look at that. TBLT provides a great environment. TBLT activates students. So according to your responses, 1 and 3, yeah, they're not correlated. Of course, the problem there is one of the concerns, of course, not a problem, but one of the concerns is that you only have 9 respondents. So maybe that's the reason. So with that in mind, a Cronbach of 0.647 is already okay, even though you have some negatively related, items here. Maybe it goes to show that there are indeed unique answers from each teacher. All right. So the next set of reliability, that's where the problem comes in. You have first, there's a warning. Okay. Each of the following component variables has 0 variance and is removed from the scale. Problem 5, problem 6, and problem 14. The problem, so to speak, with those problems is that the professors that you have, the teachers that you have, that you interview or surveyed, were in agreement uh, with each other, well, with all of them, among them, with all the items. Okay, so 5, 6, and 14. So what are those items? I have little interest in TBLT. Everybody agreed. I prefer other teaching methods to TBLT. Everybody agreed. And then large class size is an obstacle to usability. Strongly agree. Everybody agreed there. And that would not be good in alpha Cronbach. So that's why you received the negative 0.927 because of the negative average covariance among items. As said here, this violates the reliability model assumptions, and you may want to check item codings. The thing is, the main problem is you only have 9 respondents. And look at this, problem 1 and problem 2, very much negatively correlated. 0.866 and it's negative. That means the higher their answers for problem 1, the lower their answers for number 2. The higher they rate I have little knowledge, the lower they rate I have limited English proficiency. So that means they have they don't have this. They disagree that they have little knowledge, so meaning they agree. You know what I mean? So you have to look at those things, and I can't do anything to improve your data because your data is your data. You cannot change the data. Alright, unless what you will do is to do the analysis again with a little sets with some other professors and all that. Okay, on with the analysis. So the report's just fairly easy. We have descriptives, we have frequencies. I don't need to run the frequency anymore because well we can do that, but this is just for the demographic profile. I'm sure you have this. You don't even have to use spss to do this, right? So just use the, I don't know, bar charts or maybe pie charts and all that. And this is just for the frequency table, distribution, and all that. So this is how it looks like. Okay, I think SPSS is still processing it. Alright, so sorry about that. Where's that? The output is still not here. Where is it? Okay, maybe it's in different output. No, it's still running. Okay, sorry about that. So here, you have not sent me the two other respondents. So we have missing two items. Gender, one is male, one is female. There's a missing. For the age, one is 20 to 29, one is 4, belongs to the 30 to 39, 2 belongs to the 40 to 49, and there are 2 missing. And all that. So, okay, 10 and 11, 5 and 2, qualifications, 3 BAs and 4 MAs. Teaching experience, all this. Okay, there's a pie chart here, which you can do when you do when you use SPSS. Sorry about that. Okay. Okay. Now, if you want to do the analysis of the the means, so all you have to do is just look at the descriptives for P1 to P15. I'll just go straight and do everything in just one click. Okay, this is the descriptives, and I have the option to do either a mean or the sum. If you want the sum, you can just click that. Standard error of the mean. Variance is just the square of the standard deviation, so you don't need that. Kurtosis and skewness, if you want that, just tell me. Right? Kurtosis refers to how, well, you know that, right? So skewness, whether it's skewed to the left or skewed to the right, this is how flat the curve is. Alright, so if you press continue, then okay, so you will have all this. Okay, so just pay attention with the to the mean and the standard deviation statistic for everything. So 2.22. So all I have to do here is to just copy it or export it to Excel, and you have everything already. Okay. You can add this. You can have additional analysis here by dividing standard deviation with the mean, and that will give you the coefficient of variance, which will give you an overview whether the standard deviation is really high compared to the mean. So there's a normal range about 15% to 25% of the coefficient of variance, and if you do that, then it's okay. Okay, what else? What else can we do? We can do comparing of the means, and this is why I insisted that you have to have the demographic profile with you. So for example, we have the perception 1 to 15, which will be the dependent list. Alright, and the option, just click on the ANOVA table in ETA, and then the independent list will be the profile variables. Well, you lack 2 of them, and I don't want to do it anymore because I already told you, and you can't give it to me. So okay, so the thing that we will do here is to compare, for example, male versus female. Your problem is you have a lot of female. You have majority, well, clear majority, 6 female, 1 male. So with that, you can look at the analysis here. This is the p-value, the significance. So as you can see, P1 versus gender is 576, and this has to be lower than 0.05 in order to be significant, and you cannot see anything here. So what does this tell you? In terms of gender, it's not significant. Well, one reason is because there's only 1 male to compare it with, and you have a very low population, so you can't really do a lot of analysis there. Okay, so but the thing is, what is clear here is that even though the female taken as a whole tend to rate the questions higher than the male. Well, there's only one person who is male. except for some areas like P10, male is higher, P8, male is higher. So you can go through that and compare them. But the most important thing is that the difference is not significant as to, at P equals 0.5. How about age? All right, so there are how many group of age here? Age group here. You have 3 age group. Again, there's a problem because the 20 to 29 age group, there's only one there. Okay, and if you look at the analysis again of the p-value, you will end up with alright, still no significant difference. It means that statistically speaking they're equal, and age is not a factor. A while ago we said that gender is not a factor. Now age is not a factor. How about the teaching? Whether they teach in grade 10 or in grade 11. Again, let's look at this. Look at the significant. I'm looking at this. Okay, again, no significant difference for qualification, whether BA or MA. Again, we see some discrepancies here. MA, P number 1, BA, is higher than MA. P number 2, MA is higher. We have mixed results, right? You just have to go through that. And if you look at the significance level, again, you will see that nothing is significant. Everything is above 0.05. We have here an interesting result, right? P13 versus qualification has a p-value 0.074. It may not have reached the p equals 0.05 for P13, but it warrants an interesting look. 2.333 versus 3.25. The difference seems to be huge, right? And for all purposes of analysis, this could mean that it is really significant, but you only have, like 7 respondents. So that's the reason why you didn't get the significance verdict. But for all purposes of computation, it looks like if you have a bigger sample, then P13 is significant, with the MAs getting higher rating than the non-MAs. Okay, let's look at P13 again. Let's see why it's like that. TBLT, some are not very clear. Okay. Okay. Trying to get a very clear version. Okay, P13 is TBLT is appropriate for all types of group work, small group and big group. Okay, the teachers who are masters tend to score this higher, which means disagree, compared to the BA, which tends to score it a little to the agree side. So you have to figure out why is that. Maybe the kind of teaching that you have there is that the TBLT cannot be used for group work and only for a small group. I don't know. You can explain that better. Okay, what else can we do? Okay, teaching experience. So yeah, you don't have analysis here because we sort of did not group the teaching experience. If you grouped it like 6 to 10 years, 11 to 18, something like that, then maybe we could have some analysis there. So analyze again, and then maybe we can correlate. No, sorry, I'm not yet finished with the analysis to compare means when grouped according to, again, the profile variables, but this time we're gonna do the problem list. Let's see if in terms of problems encountered, whether the variables are, can say something. Okay, in terms of gender, again, we go straight to the significance level, and you can see a significant level here, which the problem 1 seems to denote, because the p-value is p is equal to 0.031. Again, problem 9 is also seems to be a concern. So 1 and 9, what else? That's it. So 1 and 9 is significant. 1 being, problem 1, male scoring it higher, very high, 4 versus 2.33. And then problem 9, again, this time, male scoring it very low. And this is significant, 1 and 9. So you have to look at that, try to find out why they scored thus. Now, in terms of age, no significant verdict. This is almost significant, problem 12. Just take a look at that. How about teaching grade? Almost significant, problem 2. Almost 005. Okay. How about qualification, whether BA or MA? This is significant. Problem 12 is significant. Let's look at that. Problem 12 is significant, and it has something to do with let me look at that. Unfamiliar topics and text are not proper for using task-based language learning. So unfamiliar topics maybe is because the masters, those teachers who are already masters, maybe they have a wider range of topics in mind because they have mastery, while the non-masters, maybe they're starting out, maybe they have not read it in some books and whatever. Okay, so yeah, so that's analysis of the mean versus the significant, whether it's significantly different. Now there's another one that you can do, which is a relationship between the two variables. You can relate the perception with the problems, right? And it's easy to do. You just have correlate and then bivariate. But the thing is, I have to have a total of each of the variables. So I have to get a total of the perception. So from variable, I think it's from variable 2 to variable, I don't know, 16 or something, and then the rest for the other one. And then after that, then you have your relationship or correlation. Okay, I will not do that anymore here, but it's as easy as clicking analyze and then correlate bivariate. Okay, so the way to do it is, of course, as I said, adding everything from P1 to P15 in Excel, and then just pasting it here, and then all the scores from problem 1 to problem 14 again, and then relating the two. Now the only concern with that is, and that's the reason also why I don't want to recommend it really 100%, is because we still have a problem with the Cronbach alpha reliability analysis of the second part of the problems, right? And if we do the relationship knowing fully well that it's not significantly, it's not consistent, you will have a problem. Okay, so that's it. That's how I show you that I can do this. Bye.